Hi, Abuelita. I'm kind of sad to hear that you were diagnosed with cancer. But luckily, we were covering cancer in class this week, so I could kind of inform you maybe what's going on. I'm sorry if it's kind of loud. I'm kind of sitting for finals right now, so I decided to be sitting at Starbucks. But first of all, let me show you a little bit what's going on. So you were diagnosed with the breast cancer. So I have a little diagram here of possibly what's going on. So this is a normal breast duct, a milk duct. You usually have a pore inside that allows for the milk to flow through. But what happened to you is most likely that your cells started growing abnormally, and so they started clogging it up. If you get into later stages of cancer, it can become invasive, where basically they grow out of normal area, and as you can see here, they can start traveling through the lymph node and traveling into other parts of the body. So luckily, I think you're at the early stages. And so one of the receptors that's basically probably malfunctioning in your body is called HER2. So you usually have these things that are called growth factors, which, I mean, you may have used earlier in your life, since growth factors are important for growth as intended by the name. But therefore, what's called tyrosine kinases. One of them does not require a signal. Most of them do, because you require the signals to kind of regulate your body. You only use them if you need them. But this one, HER2, can activate its process without needing that ligand. So I have another picture that kind of describes this. In a normal cell, you kind of have specific amount of receptors on top of a cell. But sometimes when you start having abnormalities in a cell, you can start creating more receptors than needed. So in this one is the example of HER2. You have a lot more receptors on the surface, which can possibly lead to some kind of cancer. So cells kind of regulate themselves in a way that they only grow if they need to. This is called the cell cycle. So the cell cycle is usually in the stationary phase, in the G0 phase. So it'll kind of go through a cycle of its own, and if it doesn't need to grow, it won't grow. But once it's activated, it'll start going through the whole growth process. Each step kind of developing a different part of the cell. So like in the G1, you're preparing the cell to divide by basically increasing size and whatnot, providing nutrients that it needs to grow. Then you need to make more DNA, so when you split off, both cells have DNA. And then G2 is a little bit kind of a checkpoint for the cell, and then you can go into mitosis. Mitosis is the actual splitting of the cell. So in a normal cell, you have kind of checkpoints that tell the cell to stop. In this case, what happens, I have another picture for you, full of diagrams this week. You have this specific checkpoint that you can go through. You're using a P53 signal, which basically ends up signaling over here to the mitochondria, which is the energy producer in your cell. It'll cause a release if there's something wrong. This is a signaling that happens if something goes wrong. If the cell senses something goes wrong, it'll go through this process. It'll activate BAX5. Not BAX, I'm looking at the 5 here. It'll activate BAX here. Once BAX is activated, what happens is it's going to cause the cytochrome C to be released out of the mitochondria. When that happens, cytochrome C is going to activate caspases, which is going to tell the cell to go through apoptosis. Apoptosis is basically cell death. So in a cancerous cell, what's going on is this signaling process is shut off by some mean, like the cell had to have overcome this signaling pathway, causing the cell to proliferate or grow or basically divide uncontrollably. So basically that's what kind of happened to you, or I hope this kind of helps clear up a little bit of what happened in your issue for breast cancer. I mean, it's early stages, so hopefully we can help get you good treatment, get you help, if need be, hopefully remove that part of the breast, and hopefully you'll be cancer-free and live a little bit longer for us. Well, it was nice talking to you. Have a good week.